Hey there, Adrian Rosebrock here from PyImageSearch.com, and today we got an introductory lesson on how to load an image with OpenCV using the cv2.imread function. Now, anytime you do anything with computer vision or image processing and the OpenCV library, you're going to need to load the image into memory first. So, regardless if you want to apply face detection, face recognition, object detection, object tracking, if you want to do medical image analysis, optical character recognition, whatever it is you're doing, you need to get the image into memory first. Kind of think of it, what we're doing in these series of guides is we're building our foundation. If you ever see some construction workers, you're building a house or building a skyscraper, you notice that it takes the longest for them to put the foundation down, to pour the concrete, to get the rebar in there, and it seems like it takes forever for that stage to get done. But once it's done, that building goes up super, super quickly. And the same can be said about learning computer vision in OpenCV. It takes time to pour that initial concrete, to get that initial knowledge in there, because it's a new skill. And just like that concrete needs to settle, it needs to harden, so does your knowledge. You need to give yourself a little bit of time, and you got to be a little bit patient while we're learning the basics. Because once you have that foundation done, everything else is going to go up really, really quickly. And before you know it, you'll be tackling those face detection, those face recognition, those optical character recognition problems. You'll be ready. But first, let's learn the basics, and let's start at the very, very beginning. How to load an image from disk. So, if you check out my directory here, I have the source code and example images downloaded to my system. We have two images really that we're going to be working with here today. The first one is this image here. It's a photo of me and my buddy on my 30th birthday. My wife was amazing and contacted a guy who has a Jurassic Park replica Jeep. If you're new to PyImageSearch, I love Jurassic Park. It's my favorite movie. So get used to seeing a lot of Jurassic Park references and pretty much everything we do here at PyImageSearch. I love to insert little Jurassic Park Easter eggs throughout the course. So enjoy. Anyway, so my wife was awesome enough to find this guy who had this Jurassic Park replica Jeep. We took it out on my 30th birthday, had a great time, super, super fun. So what we're going to do here is we're going to learn how to use OpenCV to load this image and display it to our screen. And then we're going to do the same for this image over here. We have this .py script here, load image opencv.py. This script, as the name suggests, is responsible for loading an input image and displaying it to our screen. And then to demonstrate how OpenCV can write images back out to disk and automatically convert file extensions, we're going to write this image here to disk using this script. And take note, these two images here are .png images, but this image over here is a .jpeg, a different file format for an image. This script, the underlying OpenCV library, automatically handles that image conversion process for us. With that said, let's pop over here to PyCharm and take a look at our script. So we start with our imports here. We have argparse for command line arguments and CV2, that's our OpenCV bindings. We then move on to parsing our command line arguments. We have a single switch image, which is the path to our input image residing on disk. Now, that's either going to be this PNG image here or this one, depending on which image switch we apply. And of course, you could pass in your own images as well. And in fact, I encourage you to do so because that's how you'll learn. You take what you learn in this course, you play with the code, you learn from it, and you extend it to your own images. So one of the first things you should do after running this script is apply it to your own images. Get that practice, develop that habit, pour that concrete. That's what we're doing now. We're building the foundation. I do want to call out, though, that if you're new to argument parsing, I want you to read this tutorial here, Python argparse and command line arguments. Command line arguments are just a fundamental skill that any computer scientist should understand. You're going to see them a lot, especially as you start working with like custom implementations, you start working with research publications. Take the time to understand command line arguments, even if you choose to execute the code in Jupyter notebooks or equivalent. That's no excuse for not understanding command line arguments. So take the time if you're new to them. Just invest a little bit in that knowledge. It'll go a long, long way. So anyway, we're going to parse this command line argument, and then we're going to load our image from disk. The function we use to load an image from disk is the cv2.imread function. And the only argument you need to pass in is the path to the input image. And we're going to supply the path here via our command line argument. And in fact, you can see an example usage up here. So the value for our image command line argument is 30th birthday.png. What it actually would be like if we hard coded it was this. So that's what would end up being insert there as the variable name for the image command line argument. Once the image is loaded from disk, it returns the image itself. Now, in OpenCV, images are represented as NumPy arrays. For single channel images, it's just a 2D matrix. And then for 3-channel images, which is what we typically work with, RGB images, those are 3-channel images. So what we can do here is examine the shape of the NumPy array. And that's going to give us the height of the image, the width, and the number of channels. Now, let's say that we have a 600 by 400 image. What does that imply? It implies that this image is 600 pixels wide and 400 pixels tall. But if you look up here, notice how we're extracting the height first, then the width, and then the number of channels. So isn't that counterintuitive to what I just said, that the width is 600 and height equals 400? Doesn't that contradict that? Well, let's think about that. Because this is a common question I encounter when I'm teaching the fundamentals of OpenCV and how images are represented. So I have this image pulled up here. Now, if we scroll our mouse across here, across the x-axis, what is that giving us? It's giving us the width. It's the width of the image. And if we go along the y-axis, that's the height. That makes intuitive sense. Now let's think of that in terms of how we may represent an image as a matrix. Well, if we go from left to right, the width is actually the number of columns in the image. And the height is the number of rows. And since we denote a matrix in terms of num rows by the num of columns, that's why we extract the height and the width. Because again, number of rows, that's your height. Number of columns, that's your width. So hence, height, width, and the number of channels in the input image. So once we have the width, the height, and number of channels, just to demonstrate that we've correctly parsed that information, we're going to print it to our terminal. And then we're going to display this new image to our screen, the image we just loaded. And to do that, we'll call the cv2.imShow function. We need 2 parameters here. This is the name of the window itself. This is going to be the title of the window. And I'll show that to you in a second. And then that's the image that we just loaded right up here. And then we call cv2.waitKey. We're going to pause execution of the script until we click on that active window opened by OpenCV and then press a key on our keyboard, and that'll advance the execution of the script. This waitKey call is just a pause. It's a waiting for user input. And the final step we're going to do is we're going to take our image that we just loaded and we're going to write it back to disk as new image.jpg. So notice that I hard-coded this file name. You could easily add in a separate command line argument to handle writing the image back out to disk as a separate file name. And in fact, that's something I recommend you do so you can start to build up your understanding of command line arguments. So now that the script is reviewed, let's go up here, we'll copy and paste the usage, pop open to our terminal, and execute the script. Let's see what we got. Our width is 720 pixels, implying that there's 720 columns across here. The height is 764 pixels, implying that we have 764 rows going up and down, and we have 3 channels since this is an RGB image. Now, notice the title here. Notice that how it says image. That's what this argument is here, right here to cv2.imShow. This window is going to keep displaying until I click on it and press any key on my keyboard, which will advance execution of the script and then write the image back out to disk. So I'm going to press a key on my keyboard. We're going to move on from this call. We're going to write the image back out to disk, and then our script will finish executing. So I want to show you 2 things. First, I want to delete this image from disk so you can see that when we run it for this script, it's going to write this image back out to disk as a JPEG file. And the other thing I want to do is show you how to change the window. So if I want to change the title of the window from image to PyImageSearch, just update that So now I'm going to go back over here. I'm going to run the script again, but this time I'm going to supply the path to this image here, JurassicPark.png. So when I execute this, we're going to see that our image has a width of 577 pixels, number of columns, a height of 433 pixels, number of rows, and this is a 3-channel RGB image. Notice the title up here has been changed from image to PyImageSearch. And when I press a key on my keyboard and advance execution of the script, we're going to have new image.jpg, which is the same image that we loaded, but as a .jpg file. So your homework from this is to run the code. Because as you go through these lessons and as you're learning computer vision and image processing, it's not enough to simply passively watch a video or read an article. You need to get your hands dirty with the implementation. And this is something you'll hear me say all the time. So, you know what? It's going to be redundant because it's an incredibly important point. Don't be passive, be an active learner. Run the code in the .zip provided with you. Run the code in the Jupyter notebook. Run the code and learn from it. Supply your own images. And 2 things I want you to do here. One is go download some other image off the internet and then supply it as a command line argument to the script. That'll give you good experience with command line arguments. The other thing that I want you to do is add a new command line argument, an output command line argument. And I'll give you a hint. It should look something along like this. See the path to output image. So using this code, how do you think you would update this line to accept an output path? I'm going to leave that as an exercise to you, the reader, to implement. Gain some experience using command line arguments. Read the argparse tutorial I mentioned earlier in this guide. Get that practice, and then I will see you in the next video when we start learning how to access and manipulate individual pixel values. I'll see you then.